Hello and welcome to today's lecture. Today we're going to talk about language of sets. First of all, let's begin by a definition. In this definition, we're going to define a set as a collection of elements like X. Sets are usually denoted by capital letters like capital S, capital A, capital B, capital C, and so on. So we say that an element like X is a member of set and we denote it by X belongs to S. So the notation that you use to show that one element is a member of a set is belongs to. If that element is not a member of the set, you just write X does not belong to S. It means that X is not a member of set S. For example, suppose A is the set of A, B, C, D. In this case, set A has 4 members. 1, 2, 3, 4 members. Note that for a set, we use curly braces to show that we have a set open and closed. Second set is set B with elements dog, cat, and a horse. Next set, set C, has 1, 2, and 3 members. The first element is a set itself, which includes 1 element. The second member is another set with 2 members. The last element is a set including 3 members. So set C has 3 members, which are sets themselves. Sometimes it's difficult to list all members of a set. Instead, we use the definition of the set like this. For example, suppose E is the set of all elements like X in N. Remember that N is the set of all natural numbers, N or natural numbers. Such that X is even. It means that X can be 2, X can be 4, X can be 6, and so on. So instead of listing all of the elements for set E, like 2, like 4, like 6, and so on, we prefer to use the definition of the set and say, hey, set E is the set of all positive even numbers. Definition of empty set. So I expect you to ask, what if we have a set with no element in it? In this case, we denote empty set by the symbol empty set, or you can write this as empty set is the same as a set with no elements in it. Let us take a look at more examples. Example 1, part A says, let A be the set including 1, 2, 3, B the set including 3, 1, 2, C is the set with some repetitions in it, 1 and 1, 2, 3, 3, and 3. What are the elements of set A, B, and C? How are they related to each other? Part B says, is set including 0 is the same as number 0. C says, how many elements are in the set including 1 and set including 1. And finally, for each non-negative integer like n, suppose u sub n be the set including n and minus n. It says find u sub 1, u sub 2, and u sub 0. Please pause the video, try to solve these examples yourself, then we go over the solution together. Very well. So set A, B, and C are exactly the same. Why is that? Set A includes 1, 2, 3. Set B, okay, here you see a change in order, but it doesn't matter since it's set including some elements. You can write 1 first, then 2, then 3. These two sets are exactly the same. For set C, you have repetition in 1 and 1. So it means that you can just write one of these elements representing all ones in the set. The next element is 2, then you have 3, 3, 3, which is repeated 3 times. You can cancel out these 2, and you have set C equals to 1, 2, and 3. So as you can see, these sets are all the same. The answer to part B is, of course not. They are not the same. Set including 0 is a different object than element 0. On the left-hand side, you have an object, which is a set. On the right-hand side, you just have a number or an integer. They are not the same. Part C says how many elements are there. It means that you just need to circle all the members, all the elements. Okay, we have one element, which is 1. The second element is set including 1. So you have 2 elements in this set. One of them is an integer, the other one is just a set. So this set has 2 members. Finally, D, for each non-negative integer n, we define set u sub n. Our goal is to find u sub 1, u sub 2, u sub 0. It means that you just substitute 1 for n, then substitute 2 for n, then substitute 0 for n. If you substitute 1 for n, u sub 1 is the set including 1 and negative 1, u sub 2 is the set including 2 and negative 2, u sub 0 is the set including 0 and minus 0, which is the same as 0 and 0, or just 0 itself. Another example, suppose R is the set of all real numbers, Z is the set of all integers, and Z with plus is the set of all positive integers. Now, the question says describe each of these sets. The first set is the set of all real numbers such that those real numbers are sandwiched between -2 and 5. Be careful, guys. You don't have any equality here. So -2 and 5 are excluded from the set. B, the domain is different. You're taking all elements in Z integers such that X is between -2 and 5. And finally, C is the set of all positive integers. Another domain such that X is between -2 and 5. Please pause the video, try to solve this example, then we go over the solution together. Very well. For the first set, here you have R, or the set of all real numbers. It means that you need to shade all the values, all numbers, radicals, fractions, all numbers in between -2 and 5. Note that 5 is not included. So you shade all of these numbers in between -2 and 5. For the second set, of course, it's a counting value. Here you can count all the numbers in between -2 and 5. So one of them is -1, the other one is 0, the other one is 1, 2, 3, and we stop at 4. Finally, for part C, it says all positive integers such that X is between -2 and 5. If you count all of those positive values between -2 and 5, it's just counting numbers 1, 2, 3, and 4. So in set A, there are infinitely many numbers in between these two. In B, you have 1, 2, 3, 4, 5, 6 elements. We can say that the cardinality of this set is 6. And for set C, you have 1, 2, 3, 4 elements. Or you can say that the cardinality of this set is 4. Now that you defined a set as a collection of elements, you can use that set and define a new set. This new set is called a subset of that bigger set. So definition, suppose A and B are two sets. Set A is called a subset of set B and you write it this way: A is included in B, or A is a subset of B, or B contains A if and only if every element, every random element in A is in set B. So you can mathematically write it down this way: A is contained in B, meaning that for any random element like X, if X is in A, then you can conclude X is in B. We can visualize being a subset by using Venn diagram. A is a subset of B. A is included in B. If A is not a subset of B, then it means that there is at least one element like X such that X is in A but not in B. Next definition is proper subset. We say that a set like A is a proper subset of set B if and only if every element of A is in B, but there is no possibility that these two sets are the same. When you look at the sets like natural numbers, integers, rational numbers, irrational numbers, real values, and complex numbers, you can actually see they are proper subsets of each other. Let us take a look at another example. Suppose A is the set of all positive integers, B is the set of all integers such that n is in between 0 and 100 inclusive. C is all the counting values like 100, 200, 300, 400, and 500. The question says evaluate the truth or falsity of each of the following statements. The first one says, is B a subset of A? C is a proper subset of A. C and B have at least one element in common. At least it means that one or more or two. D says C is a subset of B. E says E is a subset of C. Please pause the video, solve this question, and we go over the solution together. Part A is false. Why is that? Because 0 is not a positive integer. 0 is not a positive integer. So 0 is in B, but 0 is not in A. Very well. Take a look at B. B is the set of all elements in between 0 and 100, and 0 is included. But if you look at A, it's including all integers, positive ones. So as you know, 0 is not a positive integer. B, of course it is true. B says C is a proper subset of A. Take a look at C. C is 100, 200, 300, 400, and 500. There is no way C is equal to A. A is just a set of all positive integers. C is included in A, and they are not equal to each other. So, of course, it is true. Part C says C and B have at least one element in common. It is true. Why is that? Take a look at C, take a look at B. What elements are common between these two? They have 100 as common elements. D is false. C is not a subset of B. Take a look at elements here. You have 200 in C, but there is no 200 in B. You can take 300 as well. Of course, 300 belongs to C, but 300 is not a member of B. And finally, E. E is true. For any set, any random set, we can say that that set is a subset of itself. A is always a subset of A, B is always a subset of B, C is always a subset of C, and so on. Now let us talk about the symbol belongs to and symbol is a subset. Very well. So Part A says 2 belongs to the set including 1, 2, 3. B says the set including 2 is a member of a set including 1, 2, 3. C says 2 is a subset of a set including 1, 2, 3. D says set including 2 is a subset of set including 1, 2, 3. And E says set including 2 is a subset of set including set of 1, set of 2. And finally, F says set including 2 belongs to the set including set of A, set of 2. Please pause the video, try to solve this example. Very well. Only A, D, and F are true. Okay, now let us analyze this question, see what's going on. So A is true. Why is that? Okay, this is a set including 2, and you actually see 2 here. So 2 is a member of this set. It is true. Why B is not true? So the object on the left-hand side is a set. All objects inside the set on the right-hand side are elements. 1, 2, 3, just some numbers. None of these are sets. So this is false. It says 2 is a subset. Remember that when you're talking about subset, you must have a set on the left-hand side, another set on the right-hand side. On the left-hand side, you only have a digit, 2, which is not a set, so it is false. D is true. On the left-hand side, you have set including 2. This element, this random element, belongs to this set, so you say that set including 2 is a subset of set including 1, 2, and 3. Very well. Of course, E is not true. On the left-hand side, you have a set including 2. On the right-hand side, you have a set including set 1, set 2. This guy here, this 2, is not a set. This is just a digit. So this is false. This guy says F, set including 2, belongs to the set including set of 1 and set of 2. So of course you see this object here. So this is true. Notation. What's the difference between an ordered pair and a set? An ordered pair, first of all, you use parentheses to show that you have a point or ordered pair in XY plane. For a set, you use curly brackets, A, comma, B. First of all, when it comes to set, order is not important. Set including A and B is the same as set including B and A. But when it comes to ordered pairs, it's totally different. AB is not the same as B and A. You say that 2 points are equal to each other if and only if their X coordinates are the same, X coordinates, and their Y coordinates are the same. Let's take a look at one example. The first one says 1 and 2 is the same as 2 and 1 when it comes to points. The second one says 3 and 5 divided by 10 is the same as square root of 9 and a half. And finally, C, what is the first element of point 1 and 1? Please pause the video, answer this question, then we go over the solution together. The answer to A is no, they are not the same. If you use XY plane, X, Y plane, 1 and 2, 1 and 2 is a point here, 1 and 2. First coordinate is 1, second coordinate is 2. 2 and 1 is the second point here. Of course, these 2 points are different from each other. B, the answer to B is yes, they are the same. If you simplify square root of 9, it is equal to 3. If you simplify the fraction, 5 over 10 is going to be a half. So first coordinates are the same, second coordinates are the same. It means that we have the exact same point. And finally, the first coordinate and second coordinate in point 1 and 1 are the same, and they are both 1. Now, suppose you have 2 sets. Your goal is to form a new set. We can define an operation in between 2 sets. We read it as A cross B, or the Cartesian product of A and B, which gives you a 2-dimensional object, A cross B, the set of all points in xy plane, such that, with condition that A is a member of the first set, B is the member of the second set. That's the definition of A cross B. For example, consider R as the set of all real numbers. A cross B, R cross R is the set of all points, x and y, such that x is a real number and y is real number. We can denote this set by r squared or xy plane. So it gives you 2-dimensional space. You can find a cross product between R, and R, and define R cubed, your space. Includes all points in the space, x, y, and z, such that x, y, and z are all real numbers. Let us go over one example to feel more comfortable about Cartesian product or cross product between 2 sets. Suppose A is a set including 1, 2, 3. The cardinality of set A is 3. Set B includes U and V. The cardinality of set B is 2. The question says find the Cartesian product between A and B, then find Cartesian product between B and A. So you're changing the order. Finally, find the Cartesian product between B and B. Count all the numbers in A cross B, B cross A, and B cross B. And in the last part, suppose R denotes the set of all real numbers. What is R cross R? We already answered this question, but that's a good question. Please pause the video, think about this question. The cross product between A and B. All elements are first coordinates are coming from A, and all of the second elements, second coordinates are coming from B. So you get a set including 1 and U, 2 and U, 3 and U, 1 and V, 2 and V, 3 and V. So as you can see, you have 1, 2, 3, 4, 5, and 6 elements. The cardinality of A cross B is 6. Now we are changing the order, B cross A. Now all first elements are coming from B, and all second coordinates, second elements are coming from A. So you have U1, U2, U3, V1, V2, and V3. How many elements do we have? 1, 2, 3, 4, 5, 6 points, or 6 elements in the second set. Now, what if we just find the cross product between B and B? First element is coming from B, second element is also coming from B. So here you have U and U, U and V, V and U, V and V. So in total, you have 1, 2, 3, 4 elements. Remember that these 2 points are different from each other. Now that we define the Cartesian product or cross product between 2 sets, we're going to define a relation for elements in that set. Definition: ordered pair X and Y. In cross product A and B, we read it this way: X is related to Y by set R. So R is a set. If and only if X and Y is a point in R. The set A is called the domain, and the set B is called codomain. When we are talking about functions, we have domain and range. Remember that here we are talking about a relation. What is a relation? A relation is a bunch of points in XY plane. X-axis, Y-axis, here you have some points. This collection is called R, or just a relation between these points, relation. You've seen relations many times. Let us take a look at some examples. The first example is like a function, a nice function, x squared, or a quadratic function. This quadratic function takes elements in R, and it gives you x squared. Of course, it's some points in XY plane, and definitely it is a relation. Some points which follow the rule x squared. If you take the collection of these points, you have a relation. Next one is a set of numbers, elements on a circle. So here you have a unit circle centered at the origin with radius 1. You take the set of points and you call it relation, which in this case, you have a circular relation between x and y. And finally, you can take all elements, x and y, and you can define a relation using inequality. Y is greater than or equal to x. This is just a relation between x and y. Now for the rest of the relations that we can define in discrete math, take A to be set 1, 2. B with a set including 1, 2, 3. Suppose you define a relation this way. You say that x and y are in relation with each other if and only if x minus y divided by 2 is an integer. So this is just a relation, random relation that we define. Question says, first of all, state which ordered pairs are in cross product of A and B. B says, is 1 related to 3? Is 2 related to 3? Is 2 related to 2? In another word, it says, is 1 and 3 a point in the set R? Is 2 and 3 a point in the set R? Is 2 and 2 a point in the set R? And finally, what are the domain and codomain of R? R is just the relation that we defined here. Please pause the video, think about this question, then we go over the solution together. Very well, for part A cross B, or the Cartesian product between A and B, is the collection of all ordered pairs such that the first element is coming from set A, second element is coming from set B, and you list all of them. 1 and 1 1 and 2, 1 and 3, 2 and 1, 2 and 2, 2 and 3 is the set of all elements in the Cartesian product of A and B. Now, what are the elements in A cross B and which are in set R? Guys, note that we define set R to be like this. All points that satisfy this relation. X minus y divided by 2 is an integer. It's not a fraction, it's not radical. So we have to check each of these points one by one. The first element, 1 and 1. Okay, 1 minus 1 divided by 2, 1 minus 1 divided by 2 is 0 divided by 2 or 0. Is 0 an integer? Yes, 0 is an integer. What's the meaning of that? It means that 1 and 1 belongs to R. You're sure about it. The second element is 1 and 2. Okay, 1 and 2. 1 minus 2, okay, divided by 2 is negative a half. Of course, this guy is not an integer. What's the meaning of that? It means that 1 and 2 is not in R. Next point, 1 and 3. 1 and 3, take a look at this. 1 minus 3 divided by 2 is negative 2 divided by 2 or negative 1. Of course, this is an integer. So 1 and 3 is an element in the set R, in the relation R. Next point, 2 and 1. 2 and 1. 2 minus 1 divided by 2 is a half, which is not an integer. This is just a rational number. So this point is not in R. 2 and 2. 2 minus 2 divided by 2 is 0. So the outcome is an integer. What's the meaning of that? It means that 2 and 2 is a point in this relation. And finally, point 2 and 3. 2 and 3. 2 minus 3 divided by 2 is a fraction, negative a half, which is not an integer. So 2 and 3 is not in set R. So we can list all elements in set R by saying that, okay, it's going to be 1 and 1, then 1 and 3, then 2 and 2, and that's it. So this relation has only 3 elements, 1 and 1, 1 and 3, 2 and 2. So is 1 and 3 a point in R? Yes. Is 2 and 3 a point in R? Of course, you don't see it here. 2 and 2 is a point in R? Yes, it is. And C, what's the domain of R? The domain of R is the set of all first elements, 1, 1, and the 2. In the set, we don't have a repetition, so 1, 1, and 2 is just 1 and 2. Codomain is 1, 3, and 2. Since you have change of order in a set, you can write it as 1, 2, and 3. Very well. So far, we defined a Cartesian product or some points in xy plane. Then we define a relation, just a bunch of points in xy plane. Now we're interested in forming a function. Definition of a function. Official definition of a function says a function f from a set A to set B is a relation. So definitely is a collection of points with domain A and codomain B that satisfies the following 2 properties. For every element x in A in the domain, there is an element y in the codomain B such that that point is in set F. Second condition says if you take an element in A in the domain with 2 elements in codomain y and z, if these 2 points with the same first coordinate are in set F, their second coordinates must be the same. Otherwise, it doesn't pass vertical line test. So second condition is nothing but vertical line test. Let us take a look at some examples. Suppose A is a set including 2, 4, 6. B is the set including 1, 3, 5. Which of the following relations is actually a function? So which one passes vertical line test? The first relation is 2, 5, 4, 1, 4, 3, 6, 5. The second condition, the second set is all values x and y such that they follow this linear relation, y is x plus 1. And finally, set in C is the set of all elements that in A, and they are mapping to set including B with this formula. 2 goes to 5, 4 goes to 1, 6 goes to 1. Please pause the video, try to solve this question, then we go over the solution together. The first relation is not a function. It doesn't pass vertical line test. So 4 and 1, 4 and 3, of course it doesn't pass vertical line test. 1 and 3 are not the same elements. C, of course, it's not a function. Why is that? Because it doesn't satisfy the first property. Here you have 6 in the domain of the function, which is not mapped to any element in B. So always be careful about the domain of the function. Every element in the domain must be mapped to something. And T is a function. It passes all conditions to become a function.